There's a reason electricity behaves very differently depending on what it touches. Some materials shut it down immediately, while others let it flow like it was invited. And metal? Metal barely puts up a fight. The moment electricity meets it, things start moving fast. But why does that happen? What is metal doing at the atomic level that makes electricity feel so comfortable passing through it? That's the strange, microscopic secret we're about to uncover. I'm Professor Everything, and today we'll be answering the question: what makes metal conduct electricity? Right here on Explaining Everything. To understand metal conductivity, you have to understand how atoms normally behave. Most materials are extremely possessive. Their atoms grip electrons tightly and keep them locked into fixed positions. Push on them with an electric force, and the electrons barely move, like they are glued in place. Metals do the exact opposite. In metal atoms, the outermost electrons are held very loosely. So loosely that they stop belonging to individual atoms at all. Instead, they become shared electrons, free to move throughout the entire metal. Scientists often call this a sea of electrons, and it is not an exaggeration. These electrons are already wandering around randomly before electricity even shows up. When an electric field is applied, nothing dramatic has to happen. The electrons do not escape. They do not break bonds. They simply start drifting in the same direction. That coordinated drift is electric current, and metals are good at it because their electrons were never trapped to begin with. Free electrons are important, but freedom alone is not enough. If everything were chaotic, those electrons would slam into obstacles non-stop and electricity would crawl. Metals avoid this problem because their atoms are extremely well organized. Metal atoms arrange themselves into neat, repeating structures called crystal lattices. Imagine a perfectly spaced grid where every atom stays in its lane and never blocks traffic. The atoms form a rigid framework, while the free electrons move through the gaps between them. When electricity is applied, electrons do not rocket straight through. They bump, scatter, and collide constantly. But because the structure is predictable, those collisions do not stop overall movement. The electrons keep drifting forward together. The metal is not fighting them. It is quietly allowing motion to continue. Another reason metals conduct electricity so well comes down to energy levels, which sounds boring until you realize this is where most materials completely fumble the job. In many substances, electrons live in clearly separated energy zones. To move freely, an electron has to jump from one energy level to another, and that jump costs energy. If the energy isn't there, the electron stays put. End of story. Metals don't play by that rule. In metals, the energy levels of neighboring atoms overlap. Instead of neat, separated zones, you get a continuous range of allowed energies. That overlap is crucial because it means electrons don't need permission or extra energy to move. They're already allowed to exist in states that support motion. When an electric field is applied, electrons don't have to prepare, charge up, or overcome a barrier. They respond immediately. It's like pushing a shopping cart on a smooth floor instead of dragging it over a curb. The lack of energy gaps removes hesitation. The electrons just go. let's talk about resistance, because even good conductors aren't magical. Electrons moving through metal don't glide effortlessly forever. They constantly collide with atoms, vibrations, and imperfections in the structure. Every collision steals a bit of energy, which is what we call resistance. But here's the key difference. Metals don't trap electrons when this happens. The atoms stay fixed in their lattice, vibrating in place, while electrons lose a little energy and then keep moving. Nothing grabs them and locks them down. The structure of the metal limits how disruptive these collisions can be. Resistance exists, but it stays relatively low because the metal isn't actively opposing the flow. It's not fighting back. It's just mildly inconvenient. The electrons slow slightly, recover, and continue drifting forward. That tolerance is what allows a steady current to exist instead of electrical motion collapsing immediately. So what makes metal conduct electricity comes down to a simple combination. Metals hold their electrons loosely, arrange their atoms neatly, and allow energy levels to overlap freely. That creates an environment where electrons can move easily and respond instantly to electric forces. Electricity does not force metal to cooperate. It exploits a system that already favors motion. Other materials cling to electrons and block pathways. Metal shrugs, steps aside, and lets the flow happen. Once you see it that way, metal conductivity stops being mysterious and starts feeling inevitable. If you enjoyed this video, or if you are now cautious doing electric work in your house, leave a like and don't forget to subscribe. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. If you enjoyed this video, please check out our other bingeable channels. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.